Voltage is the electrical pressure or force, and it is measured in volts, which is written as V. And then there is current, which is a stream of moving electrons, and is measured in amperes, which is written as A. And then finally we have resistance, which is the opposition to the flow of current, and it is measured in ohms, which is written like shown. Ohm's law tells us how to find voltage, which is by multiplying current times resistance. So if we were trying to find the voltage of a current with a resistance of 100 ohms and a current of 2 amperes, the answer would be 200 volts, because voltage is equal to the current times the resistance, and 2 times 100 is 200.
In a series circuit, the total resistance is equal to the sum of all resistors. It is also important to know that the current is always the same. Okay, this is a small practice problem for series circuits. To find the resistance total, you add up R1 and R2, which becomes 300. Now we're at parallel circuits. The voltage across each branch is the same, and the total current is the sum of all the currents flowing through each branch. We know that the resistance total is equal to 300, and we can use Ohm's law to find the current total. So the current is equal to voltage over resistance, and current equals 3 over 300. So the total current becomes 0.01 amps.
Since we now have the current total, we can find the voltage going through each resistor by multiplying the current total to the resistance of each resistor, making the voltage going through each resistor 1 and 2 volts.
In a parallel circuit, resistance total equals 1 over resistance 1 plus 1 over resistance 2. Here is a parallel circuit practice problem. We're trying to find the resistance total, and we know the formula for this. This is 1 over 300 plus 1 over 200, which results in 120 ohms. We can find the current total by dividing the voltage over resistance total, which results in 0.083 amps. With the given information, we can find the values for current 1 and current 2. So for current 1, we divide 10 volts by 300 ohms, and the result is 0.033 ohms. For current 2, we divide 10 volts by 200 ohms, resulting in 0.05 ohms. Voltage is the same throughout.
Here is an example of a complex circuit. We can solve this by finding the resistance and the current of the parallel circuit, and then after finding that, we can plug it in and make it a series circuit. We first find the total resistance of the parallel circuit in this whole circuit. We do this by using the previous equation of 1 over resistance 1 plus 1 over resistance 2. And after plugging in the values of the resistors in this complex circuit, we get 1 over 50 plus 1 over 20, which equals 4 ohms. We know the resistance of each resistor because it is already given. Resistor 1 is 6 ohms, resistor 2 is 5, resistor 3 is 20. So because we found the total resistance of the parallel branch, we can cancel out the 5 ohms and the 20 ohms and find the total resistance, which is going to be 6 plus 4, which is going to equal 10. The total voltage is already given, so that the total voltage is 30 volts. And by using the Ohm's law, we can find the total current, which is going to be 3 amps. And because in a series circuit, all the current is the same throughout, we know that the current through resistor 1 is going to be 3. And now using Ohm's law, we can find the voltage going through resistor 1, which is 18, because 3 times 6 is 18. Because the total voltage is 30 and the voltage through resistor 1 is 18, we know that the voltage throughout the parallel circuit is 12, because 12 plus 18 is 30. So voltage 2 and voltage 3 are each 12 volts. Now using the Ohm's law, we can figure out the current through resistor 2 and resistor 3, which is going to be 2.4 and 0.6.